Welcome to Lesson 3 on double replacement reactions. Our lesson objective: complete double replacement reactions to determine if the product is soluble or insoluble, as we did in our previous lesson using Table F. Double replacement reactions involve two aqueous ionic compounds mixed together so that the reactants will switch partners and form new compounds. And for a double replacement reaction to have taken place, one of the products must form a precipitate, meaning an insoluble solid. And Table F will tell us whether the products are soluble or insoluble. For example, here's a double replacement reaction. We have our two aqueous reactants forming one insoluble solid or precipitate as a product, and the other one will be aqueous. And notice that they switch partners. Pb combine with bromine to form lead bromide, and sodium combines with nitrate to form sodium nitrate. So how do we complete a double replacement reaction? Well, recall that when we place ionic compounds into water and form aqueous solutions, they're going to dissociate into ions. So they're going to ionize. We have sodium form the positive ion, chlorine form the negative, silver forms positive, and nitrate forms a negative. And so these ions are now floating around in solution. And so if a reaction is going to take place, that first step is already done as they're in solution. So now our sodium is going to combine with nitrate now, and the silver is going to combine with chlorine. So they're switching partners to form these two new compounds. So the first thing you have to do is when you form these new compounds, you have to look up the charges of each ion. So sodium is +1. Table E tells us that the nitrate is -1. Silver is +1, and chlorine is -1. And we have to then make sure that the sum of our charges in our compound equals 0. If they don't, then we add subscripts to make that equal 0. And then we're going to use Table F, as we did in our previous lesson, to determine which, if any, of the products forms a precipitate. So here's an example. Complete the following double replacement reaction and determine the insoluble product, if any. So we're going to take silver chloride and sodium sulfate. And so the first thing that's going to happen is that when we place this silver chloride into water to form the solution, it's going to ionize. It's going to dissociate. Remember, that's why these are electrolytes, because they can conduct electricity due to these charged particles. And the sodium and the sulfate will separate. And so now we have these charged particles, and what's going to happen is they're going to switch partners. And so the silver is now going to combine with sulfate, as we see here, and the sodium is now going to combine with chlorine, as we see here. So they switch partners. That's why it's a double replacement. And now I want to look at my charges and make sure that they equal 0. So silver is +1 and the sulfate is -2. So we have two negative charges and only one positive charge. So I have to add another positive charge. So I'm going to add another silver with my subscript 2. So now I have two positive charges, two negative charges. So my formula is Ag2SO4. And let's do the same thing here, +1 and -1. This does equal 0, so this is a 1-to-1 ratio, and that is already set. Next thing we're going to do, look on Table F. And so let's look up this anion sulfate. I'm going to find sulfate here. It's in our soluble column. We're going to check our exceptions, and it says except when combined with Ag+. So when it's combined with Ag+, it's no longer soluble, it becomes insoluble. So that's going to be my solid precipitate. And then we can just look at the other one here just to make sure we did this correctly. So look up NO3, nitrate. All nitrates are soluble, so that's going to form my aqueous product. That's going to dissolve. Let's see another example. Complete the following double replacement reaction and again determine if the insoluble product forms and which one does form that insoluble product. So we have calcium bromide and magnesium carbonate. And so first, we're going to dissociate our ions, as we can see here. And next, we're going to switch partners. So the calcium is going to combine with the carbonate, and the magnesium is going to combine with the bromide ion. And now let's check our charges, +2 and -2. So those equal 0. And so therefore, this is a 1-to-1 ratio. This is already done. And now let's look at the next two ions. So magnesium is +2 and the bromide is -1. So we have one extra positive charge. So to balance that out, we need another negative charge. So I'm going to put a 2 here for 2 bromides. Now let's bring up table F. Let's look up CO3. I see that's here. This is in the insoluble column, so that means it doesn't dissolve. Let's check our exceptions. Except when combined with group 1. Well, calcium is a group 2, so that's not going to be an exception, and obviously it's not NH4, so this is going to be an insoluble product. That's going to form our solid precipitate. And then we look up bromine, Br. That's in my soluble column, and magnesium is not one of the exceptions, so that's going to be soluble, that's going to dissolve, and so that's going to be my aqueous product. And let's see one more example. Again, we're going to complete the following double replacement reaction and see if a product is insoluble. So we have sodium nitrate and aluminum phosphate. And so we dissociate our ions. And now we're going to do our double replacement. So sodium is going to combine with phosphate. And aluminum is now going to combine with nitrate. Let's check our charges. We have +1 here, and we have a -3 here. So that means we need +3 or 3 positive charges. So we're going to put a 3 as a subscript for sodium. So now I have 3 positive charges and then 3 negative charges for my phosphate ion. And then do the same thing here. I have 3 positive charges for aluminum and only one negative charge for the nitrate ion. And so I need 3 negative charges. So I'm going to put it in parentheses and put the 3 outside, indicating that I have 3 negative charges. And so now that's balanced out. So now let's bring up table F. Let's look up phosphate. We see that's right here. That's an insoluble, in the insoluble column, meaning it doesn't dissolve. But let's check our exceptions, except when combined with group 1. Okay, so we see here sodium is a group 1 ion, so therefore that's an exception. So that actually means it's not insoluble, it is soluble. It will dissolve, so that would form an aqueous product. And look up the next one here, NO3. All nitrates are soluble, no exception, so that's also aqueous. So actually, this reaction would not take place. And so we would not actually form these products. And so we would write no reaction. So let's check your understanding. Can you complete double replacement reactions to determine if the product is soluble or insoluble using table F? At this point, you should be able to complete double replacement reactions to determine if the product is soluble or insoluble using table F.